Holy swear word, guys. I just started looking up into the future and kind of checking on how many more videos I needed to make for the rest of the semester, and I have less than 10. That's so crazy. I can't believe I made all these videos. I can't believe we started at vectors and now we're at calculus. I wasn't even that great at vectors. And now we're all the way at calculus. You've stuck with me the entire time. So, round of applause and give yourself a pat on the back. That's fantastic for you guys to spend your extra time watching these kinds of videos. Oh, except for my class. My class, I'm making them watch these videos. No pat on the back for you guys. You're doing this because you have to. Okay, because you want this credit. Anyways, we have one more video after this guy and then 2 units which are super short, and then that's it. Then summer. So let's get started. This is lesson 7.4 and we're in our last section of special derivatives, which is trig derivatives. Okay, so I'm going to teach you in this video how to do the derivative of sine and cos. Now, deriving the actual derivative taking the different, what am I trying to say? I don't know. I'm just really excited right now about the lesson 10 videos. All right, trying to figure out the derivative of sine x. You can use the n-spire calculators. I kind of showed you in one of the previous videos how to do that. And so above where it says limit as x approaches 0 of the function sine x over x, if you use your n-spire, I'm going to go a little bit fast, you're going to get the answer 1. And that's going to play in a little bit. Over on the right hand side, cos x minus 1 over x as x approaches 0 is going to give you a 0. Okay, so you can try it out on the n-spire calculator or you can just take my word for it. So now if I wanted to take the derivative of sine x, I would do, and I'm not going to go through all this, okay, an algebraic proof. And so I started with first principles. I think you can follow through most of it, although what I'm going to show you is being able to do this part, so just this guy, you're going to need the compound angle formula that you learned last semester in advanced functions. Okay, and so that is like sine of one times cos of the other, right? Plus, and then cos of one and then sine times the other. That was the compound angle formula for sine. Now skipping through the rest, because I think you guys can follow, I'm just going to scroll through really slowly and you guys can pause it if you want to. Eventually what happens here is you'll see that there is a splitting up of both of the limits. And what I'm trying to get to is isolating each one of these into limits. So these guys, I mean, there's 4 of them, but I do want to show you that I can't sub h at 0 into anywhere in the sine x because there's no h's, and so I'm just left with sine x. But at the very, very beginning, when I told you to play around with the n-spire calculators, I told you the answer to this, and that's just 0. Again, I can't plug in 0 into any h's because there are no h's in cos x, so we're going to get the exact same thing. And again, at the very beginning when I told you to play with the n-spire calculators, we would have gotten something that equals to 1 for this last box. Okay, now when I have sine x times 0, it's going to disappear. Okay, so that's what I got right there. And you'll notice that doing all of this, you finally figure out, oh, the derivative is cos x. So the derivative of sine x is cos x. Now you can do the exact same thing for cos x, but why don't I just tell you? Okay, let's just say that a different function, you have cos x, that's a cos, I'm so sorry. Okay, g prime at x is going to be, dun, 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 I know you're going to be like sine x, you're not wrong actually. Sine x, but with a negative. Okay, so derivative of sine is cos, derivative of cos is negative sine. And I guess, I mean, like if you really want to, you guys can figure out too. Sorry to jump, because I know you guys are going to want to know. What is the derivative of tan? Right? So why don't you guys figure it out? Tan is just, oh, no. You know what? Before I jump into derivative, I'm just going to fiddle with it. sine x over cos x, right? That's not the derivative yet. So why don't you guys do the quotient rule and figure out what that equals to. All right, I'll just tell you. 1 over cos squared x. Or in other words, secant squared x. Okay, but why don't you guys try it out, see if you get the same thing. Okay, so let's start doing some examples. Notice that all of these, they kind of look like things that we've differentiated already, but obviously we're sticking trig in there. And then example 5 is just like, hi, let's be annoying, and also stick in a ln. Okay, so it's okay, we'll figure this out. Y prime. Okay, because y is already isolated by itself. It looks like some sort of a product rule. And so I'm going to break it up. I'm going to do this one and this one in blue and green. Okay, so product rule is derivative of the first, which is 2x. Don't touch the other one. Plus. Okay, derivative of the green. Now, derivative of the green is going to be negative sine x, and keeping the blue. Okay, so there you go. The derivative is finished. I mean, you can start to work with it and just simplify it a little bit if you like. So we have 2x cos x, and this will be a minus. And I like to put the x squared first because it looks like sine x, and it really doesn't matter. But it almost looks like x squared is like a smaller thing, and then sine x is like a larger thing that I put at the end. I think it would look weird if you put sine x, x squared. Like, that looks weird. Okay. And we can simplify even farther if we wanted to, if you actually notice that this is one term because it's multiplying, and this is another term. So what do they both have in common that you could probably factor out? So we could common factor something, and that looks like the x's. Like, both of them have at least one x, and so I could common factor an x out, and it would look like this. Equals, take that x out, and then you are left with 2 cos x minus, and then x sine x. All right, so it really depends on how far your teacher wants you to go. Every teacher is going to be a little bit different, and so either the first, second, or third step would be a great ending point for this question. All right, let's go on to the next one. Jumping right away into the derivative. Okay, so this is definitely a chain rule. You can see that there are different layers going on. There's a sine layer, and there's also a 3x layer. So deal with the outermost layer first and work your way in. So do the derivative of sine first, and what that would be is you get cos. Actually, you know what? Why don't I do this in the different colors again? Okay, so we'll do this one as an inner layer and the sine as the outer layer. So cos is a derivative of sine. Don't touch this layer yet. The next step will be continuing that chain rule. Now you do the derivative of the green part. All right? And again, you can simplify it a little bit if you wish. I would just pull this, because it's a coefficient by itself, into the front. 3 cos 3x. This is not like you can't take this and multiply it in here. It doesn't do that. Okay? Cos is very much stuck to the bracket behind it, and so it will not interact with that 3 unless it's just multiplying it at the front. All right, so far so good? Okay, let's keep going. Sorry, I'm like taking a little bit of time because I'm just checking over my work. Sometimes I make these videos and I'm like, did I actually do the right thing? I just talk, and hopefully, but then I get comments like, Miss, you forgot a negative. I'm like, ah, man. Okay, do you guys see all the layers? We got the inner layer. We got the outer layer. Okay, do the derivative of the outer layer first. So the derivative of cos is negative sine, but you're not dealing with anything inside the bracket yet. Okay, so you're just dealing with the derivative of the cos. Everything else stays the same. Now you're going to multiply the derivative of the inside layer, which is 3x squared. Okay, so again, that x cubed and the 3x squared, they don't interact with each other. It's almost like bedmass. So sine is going to interact with the x cubed behind it before it allows the brackets to interact with each other. That means the only thing I would actually do is probably just pull this into the front. Y prime equals to negative 3x squared times sine of x cubed. That's all I would do. And it's not even like you're simplifying anything, it's just you're just rearranging stuff. Okay, keep going. Now we're talking about exponents. So let me be very clear as to what this actually means. That cubed right there is y equals to sine x with a cubed. All right? It's not sine x cubed, because that means the cubed is stuck to the x. This cube means it's stuck to everything, the sine and the x. Okay, so now that I've written it out, why don't we just think of it this way and then we'll do the derivative. So again, I see lots of layers. The outer layer is this 3, and the inner layer is this guy. So let's do each one separately with a chain rule. Y prime is deal with the outermost layer first. Okay, take that 3, bring it down. 3. Don't touch anything on the inside. Keep it exactly the same because you're just dealing with the exponent. So you're going to do 1 less than that 3. Now you deal with the inner layer. So the derivative of sine x is cos x. Okay, and I don't even know if I could really do anything to that. It looks pretty simplified already. So I probably would just leave it. All right, now we got to the hard one. Example number 5, you have a ln and a cos in there. So again, check out the layers. Here's the outermost layer. This is the innermost layer. So do each of the derivatives separately. Okay, y prime. Deal with the ln first because it's the outermost layer. Okay, so remember the derivative of ln. Here, why don't I scroll up just a bit and I'll just remind you. If you have y equals to ln x, the derivative is going to be 1 over x. So whatever you have here is going to go underneath. Okay, so I'm hoping this makes sense to you. The derivative of ln cos x is 1 over cos x, because whatever is here goes basically underneath. So notice that the cos x hasn't been dealt with yet. Like you haven't actually done the derivative of the cos x yet. That means that the chain rule says, okay, it's my turn. Do the derivative of the innermost layer, negative sine x. And you can clean it up. Just simplify a little bit. Equals to negative sine x in the numerator over cos x. And hey, isn't that tan? Like negative tan x. Again, I don't know where you can stop. It's subjective. You stop wherever you or your teacher wants to stop. All right, so, okay, how many layers are there here? Jesus, okay. Let's write that out again. Okay, let's see. Y equals, you don't have to do this step if you don't want to. It's just this 3 always throws me off. So it's sine x squared minus 1. And the entire answer is cubed. Okay, so let's take a look at all of those layers. We have this one on the outside, which is probably the one I'm going to deal with first. Then we have this one on the inside. And then we have this one on the inside. Okay. All right, let's do the derivative. I hope I have enough space. I don't know if I'm going to have space. Let's see. I'm going to move you down here. Okay, y prime. Let's deal with the 3 first. So bringing the 3 down, you're going to have everything inside not touched. and 1 less for the exponent. So I'm going to just fill in everything that we had before. X squared. I don't know what happened there. I think that just glitched a little bit. I love you too, smartboard. Okay, x squared minus 1. All right, so we dealt with the blue. Now we're going to deal with the green next. So the green, you want the derivative of sine, which is going to be cos. And don't deal with the red yet. So you're going to keep red exactly the same way it was before. Now it's the red's turn, so you're going into each of those layers. The derivative of the red is going to be 2x. And again, you can clean this up if you want. So personally, what I would do is, it looks like I have a coefficient right here and right here. Why don't we put those guys together? You got a 6. Okay, and I don't think the rest really matters too much. I mean, you could put the cos x squared minus 1 first, and then just put the sine. Oh my gosh, I forgot there was an x. Don't forget that. That's still there too. We're just going to hide it in the front. I knew that all along. 6x. Okay. Sine x squared minus 1 squared. Personal preference, it doesn't really matter. I mean, whatever aesthetically makes sense to you. As to what order you want to put things in, totally up to you. So obviously, we always ask this question. Find the equation of the tangent, and let's just be a little bit extra and make you do it to the exact answer. No calculators. Or maybe calculators, if you have a good calculator. Find the equation of the tangent to, and then they'll give you a certain function, at x equals to pi over 6. Okay, so we've done this many, many times before. The only difference is now the f at x, the original equation, is going to have some trig. Okay, and that's fine. So let's take the derivative. I put these into certain colors, and so let's grab my pink, and whoops. I believe I had done this guy in pink, and then I did the other one in a very nice blue. Okay. Right there. All right, so derivative of the top first, using quotient rule, will be your cos x times the bottom minus the derivative of the bottom. So the bottom has 2 layers, right? You're going to have to do the derivative of the cos and the 2x, which is this part. Okay, multiplied by the top, don't touch the top, all over bottom squared. So far, so good? Don't simplify any of that. Just immediately sub in this guy. You're going to get the same answer anyway, but you could probably make more mistakes if you tried to simplify first. So just sub in everything and calculate. Now, I'm not going to go through how I got my answers from the first step all the way to the third step. I mean, I would just use special triangles, to be completely honest. Pi over 6 is the same as, what is it, 30 degrees? And so using special triangles, you should be able to get some pretty familiar numbers. All right, and that's how we're going to keep it exact. If you just punch it all into your calculator, you could potentially get decimals. So try to use your special triangles and plug everything in this way and simplify. And so it looks like my slope is 3 root 3, which is a nice, clean, exact number. But they asked us for the equation of the tangent, so I'm going to need an x and y. We're going to use the same pi over 6, but we're going to sub it into the original equation and get a y value. And so here is my x value. This is going to be my y value. And so I get my point, x and y, which I could then sub into my equation of my tangent. Okay, so there's my x, there's my y, I got my m, and I'm going to simplify it. I get one nice big fraction for b, and so I'm going to put my slope in and also my y-intercept. All right. So the last video in Unit 7 is going to be on applications. So that's going to be 7.5, and that's it. That's our last lesson for Unit 7. I think there's maybe 4 or 5 for Unit 8, and then maybe another 4 videos for Unit 9. So the end is in sight, the light at the end of the tunnel. My summer is like, what do you guys call it? You guys call it like senioritis or something? Do I get to have senioritis? Because I feel like I have senioritis. Okay, see you later, guys.